Yeah, it's actually a leading, trailing asymmetry. So the side that's going forward in the I'm trying to remember which side it is. The side that's going forward in its orbit is the dark side, I'm pretty sure, and the side that's trailing behind in the orbit is brighter. So one idea was that it was sort of collecting dust on its front side, sort of like bugs on a windshield. But the problem is that hasn't happened to any of the other satellites of Saturn. So why would that only happen to Iapetus is a question.
Is it possible that it was all dark and directly in a collision?
Yeah, and somehow you deposited a bunch of ice on the surface. Yeah, people have proposed that.
What a comment.
Yeah, I'm sort of reserving judgment on, on what the best idea is. One thing you might notice, actually you can't see it very well on the screen here. I'm going to rotate this around to the dark side, and you'll see that there's some interesting features over there too. So here we are going from the bright side to the dark side. The transition, trying to get pictures of the transition area is so difficult because the contrast is so huge. I mean, I didn't even stretch this in Photoshop or anything. That's what it looks like. And here's a picture of the dark side where it's been enhanced to see what's in that dark material. There's a lot of craters, obviously, so the surface is really old. But this is a big mystery. There's this huge ridge going along here, and all these question marks pointing at it. The ridge can get up to about 11 kilometers high. It's huge. And it's perfectly straight. And here's the mystery. It perfectly follows Iapetus's equator. Almost as if, somebody was like making a globe and too much glue squeezed out or something.
It doesn't appear to be any ejected around the craters where it's white, so that...
Yeah, it looks like the frost has sort of like covered over any ejecta that might have been there. Yeah, like the frost is much more recent. Yeah. So this frost is probably active and mobile. But the origin of this feature, which people are starting to call the belly band, is a big mystery. And it has something to do probably with Iapetus changing shape in the past. Unfortunately, none of the pre-made theories can explain it.
Where that line seems to terminate, it looks like it goes into a chasm, or like a wire feature.
This is a big crater here, and this has come along later and wiped out that ridge. So we've been able to trace the ridge over about half the surface, but it's been wiped out by a couple of big impact craters in a few places.
It's almost like the saucers.
Sorry, what'd you say?
It's almost like the saucers.
Yeah.
Large edge to it, and it just seems like it's been building up.
Yeah, exactly.
Area and the edge is still visible.
Yeah, so people have had different ideas of like, well, could there have been like a ring, and it's sort of like all accumulated onto Iapetus's equator. Unfortunately, I guess Iapetus's orbit is a little bit tilted, and so you would never get it only just on the equator. It would sort of be spread out over the whole body. Some people have called this the eye ring, trying to figure out what's going on. Saturn's rings all have letter names, by the way. Yeah.
Like on the moon, the reflective part is a different rock composition. It's more reflective. Could it just be that there's different minerals and the albedo is just very low? On that side.
But we know that the white stuff is water ice.
You know it.
Yeah, I mean, it's easy to get good spectral data from that because it's nice and bright. You can even do it from the Earth with spectrometer. You can see water ice on the surface there. But the dark material, it doesn't show a lot of distinctive features. And I'm not actually a spectroscopy expert, so I can't speak to the details of that. But we know it's not water ice. It's got to have... There might be water ice beneath some dusty layer. I mean, it's possible that, down deep there might be water underneath some kind of deposit of dark material. But if you notice, a lot of these craters don't punch through the dark material into something brighter underneath. So whatever's covering the surface there must be pretty thick. Did you have a question?
How come if that's water ice, the bright area? How come it doesn't sublimate out into space?
Well, it does slowly. Yeah.
So if it's doing that, then this would be a fairly recent thing then?
it will sublimate out into space, but out by Saturn, we're pretty far from the sun, and it's cold. It's like when it gets warm, it gets up to maybe 100 Kelvin, which for those of you who don't know the Kelvin temperature scale, that's 170 below Celsius, over 300 below Fahrenheit. Okay, so by warm, that's actually really, really cold. Ice will slowly evaporate at that temperature into a vacuum, but it takes millions and millions of years. And it's still possible to have water ice frost stick around for a long time at those temperatures.
So it's being renewed.
Yeah, so something's happening to renew this water frost. And so some people have the idea that maybe there is water ice that's mixed in with the dark gunk here, and it's going to get warmer on this side because it's darker, so it absorbs more sunlight. So you liberate the water, then it goes up, and it finds some bright area where it's much colder, and it gets cold trapped up there and forms a sort of frost deposit.
It couldn't be coming from outside the satellite. It's coming from within the satellite, probably.
Yeah, there's not much water just floating around Iapetus in space. So. I'll show you some pictures later. Let me come back to that.
Does that equation go all the way around, or just on the dark side?
Yeah, we don't have good enough data to map it all the way around. We've mapped it around about halfway, and it gets interrupted on one side by a crater, and on the other side we sort of lose the image coverage. There's a few hints of it on the bright side, but it's harder to spot on the bright side, unfortunately. And here's just a closer up picture of that belly band, so you can see how far it sticks up above the edge of Iapetus here.
That's it.
What size is that one anyway? About the same size as ours? Or
Sorry, what size is what?
What size is the moon?
Oh, I'm sorry. Yeah, I meant to point this out when I had this slide up. Okay, so here's all the moons of the outer solar system together. These three moons, Ganymede, Callisto, and Titan, are all planet-sized bodies. They're all actually larger than Mercury and a little bit smaller than Mars, which is about half the size of the Earth. Okay, so these things are roughly about 5,000 or 6,000 kilometers across. These guys are about more like 1,000 to a few hundred kilometers across.
Our moon would be about the size of.
Our moon is approximately. Well, it's a little bit smaller than Europa. It's about this size. And here's Iapetus, so that's quite a bit smaller than our moon. Yeah, maybe about half or a third the size. Okay, let me get past this. All right, let me just show you one other of these medium-sized satellites here, Dione. And this is a common theme in Saturn satellites. Dione, Rhea, Tethys, a bunch of these medium-sized satellites show this, where they have these ancient crater terrain, and then there's all these bright streaks going across the surface. And when we get closer to the surface, we find that these streaks are actually big fractures cutting across everything. They cut all the craters apart. They seem to be one of the youngest features on the surface. So an ancient surface with recent fractures on top, and what caused them, we don't know yet. Something has pulled apart the surface of a lot of Saturn's moons sometime recently. Not like way back in ancient solar system history, but sometime in the latter part of
They look like scrapes, but they're fractures.
Right. Yeah. So these are actually places where the surface has been pulled apart. Either by one idea is that you might have some kind of motion in the ice below that's actually ripping the surface apart. Another idea is that you might have tides that are raised by Saturn that are forming the satellite, cracking